Okay, example 2. You're told that these sweets, these yummy sweets, are sold in tubes of 15 sweets per tube. 20% of those sweets are blackcurrant. And the question says, what's the probability that you choose a tube? What's the probability in your 15 sweets? What's the probability of getting 3 or more blackcurrant ones? Now that's just a straightforward binomial. If we let x equal the number of blackcurrant sweets, so the number of blackcurrant sweets in a tube, and the tube contains 15 sweets. So we know that x has a binomial distribution where n is 15, and the probability of success, in this case success is getting a blackcurrant flavoured sweet, is 0.2. And the question says, what's the probability that the number of blackcurrant sweets is 3 or more? So greater than or equal to 3. Greater than or equal to 3 means 3 or 4 or 5 or 6, anything up to 15. So we're going to do 1 minus the probability that x is 2 or 1 or 0. So 1 minus the probability that x is less than or equal to 2. Now we can't... Now, unfortunately, we can't use the tables here because the tables only work for a binomial where n is 14 or 16. So we need to actually work out 1 minus the probability that x is equal to 0 or 1 or 2, which is a bit of a pain, but there you go. So it's going to be 1 minus. Now for x equaling 0, we're just going to do 15c0 multiplied by 0.2 to the power 0 times 0.8 to the power 15. 1 is going to be 15c1 times 0.2 to the 1 times 0.8 to the power 14, and then that's plus 15c2 times 0.2 squared times 0.8 to the power 13. Now if we work all of those out, you have to get your calculator out here, use your memory. 1 minus, the first probability just comes out as 0.0351. Save that in your memory. The next one is 0.1319 in your memory. Next one 0.2308. So if you save those up, add them together, subtract from 1, ends up as 1 minus 0.398, and that rounds to, and that comes out as 0.60197, which I'm going to round to 4 decimal places, 0.6020. Now the question becomes a bit more difficult because along comes Robert and he buys 5 tubes of yummy sweets, and each of those 5 tubes contains this 15 sweets. And the question says, what's the probability that at least 4 of his tubes contain 3 or more? Now we've already worked out the probability of 3 or more blackcurrant sweets appearing in a packet of 15. So we've already done part of it. But the question now goes on to look at 4 tubes. So everything's now changed. We've now got a binomial where y is equal to the number, not the number of blackcurrant sweets, but the number of tubes of sweets containing 3 or more blackcurrant. So 3 or more blackcurrant flavour sweets. Yeah. Okay, and y is going to have a binomial distribution. Now this time he is buying 5 tubes of sweets, and we have to think now what the probability of success is going to be. Now success now is getting a tube which contains 3 or more blackcurrant sweets, and the probability of getting a tube that contains 3 or more blackcurrant sweets is this. So I'm going to put here 0.601, and we should use the accurate version there, 0.60197. So the question now says, find the probability that at least 4 of the tubes contain 3 or more. So what we actually want, if y is the number of tubes containing 3 or more blackcurrant sweets, we want the probability that y now is greater than or equal to 4. Now, n is only actually 5 here, so greater than or equal to 4 means the probability that y is equal to 4 or 5. So there aren't too many probabilities to work out there. So the probability that y is equal to 4, well, n is 5, so it's 5c4 multiplied by success, well, that's 0.60197, happening 4 times. Let's just put a multiplication sign, and that is multiplied by 1 minus, in other words, this is your Q, 1 minus 0.6019, and that's going to be to the power 1. Now the probability that y is equal to 5 is 5c5, well that's just going to be 1. Success again, so that's that 0.60 to the power 5, multiplied by the 1 minus 0.60, and that's to the power 0. Well actually that's just 1, and that's just 1. So if we carry on, a 5c4 is actually just going to be 5. Anyway, we can stick this all into a calculator. The first bit there comes out as 0.2613. And the second one over here, this comes out as 0.0790. And if we add those two together, because it's the probability of 4 or 5, it comes out as 0.34038, which is 0.3404 to 4 decimal places.